Good afternoon, everyone. Myself, Sachin B., working as an assistant professor in the Department of Mechanical Engineering from Maharaja Institute of Technology, Mysore. In today's session, I am going to deal with the second part of the module 1, that is transducers and sensors. These are the topics I am going to cover in today's class: introduction, transducers, classification of transducers. If the time permits, I will go for the sensors and its classification. Before going to the introduction of the transducers, sensors and transducers are art of any of the mechatronic system. Without transducers and sensors, it's very difficult to complete any of the automate system, or very difficult to automate any of the processes, because this will going to act like a sensing element, and also it will going to convert one form of energy into another form. Before going to the definition of the transducer, we should know about the generalized measurement system, the block diagram of generalized measurement system. Here I have written the block diagram of generalized measurement system. The first is input device, and the second it is signal conditioning, and the third one is output device. Here the input device will going to generate the input. That input will be in one form. That input will be conditioned in signal condition, that will get transferred to the required form in the output device. Means one form of energy is get transmitted to another form. That is generalized measurement system. For this, I have taken the example of a dish TV, where in a home appliances we are using the dish, set-top box and the TV. Here we can see the diagram. Dish will going to receive the electromagnetic waves from the satellite. Through that electromagnetic waves, the signals are passed to the set-top box. In set-top box, to the required form of the output in the monitor display of the TV, the set-top box will going to get changed the signal into the display format in TV. Means here the electromagnetic waves will be get converted into display form. That is a very good example for generalized measurement system. By knowing these concepts, next I am going to explain the definition of transducer. Before explaining the definition of transducer, we should know the meaning of what is the meaning of transducer. Trans means change, induce means induct or provide, means some changes will going to happen in any of the system from converting one form to another form. Here I have written the first definition of transducer. Transducers are the devices when actuated transforms one energy from one form to the other form. Means here one form of energy gets transmitted to another form. One form of energy is get transmitted into another form, whether it is a mechanical energy or mechanical form to mechanical form with the help of mechanical linkages. Means rack and pinion arrangement. There linear motion or rotary motion is get transferred to the required form. In similar fashion, in many of the devices, when it's come to the electrical energy will be get transmitted to electrical form or the required form. Next, on one more definition I have written at the bottom. Transducer is a device which transforms a non-electrical physical quantity into an electrical signal. Means one form means non-electrical signal, whether the sound wave coming out of the device will get transferred into the electrical signal. For that, very good example is mic. If I speaking in mic for long duration of time, many of them have observed how the sound waves are getting transferred into electrical form and how it is coming out of the speaker. There sound energy is going to affect on the diaphragm of the mic. Within that mic, diaphragm will be there. With help of the diaphragm will get displaced from its original position to the displaced position. Means from original position it will get moved to the another position, due to which the transfer of energy will going to take place. Means there the sound energy will going to make the displacement. With help of it, the electrical signals are get passed to the device. That is a very good example for the transducer definition. Next, I have written the classification of transducers, how they will going to classify the transducers. Here I have written 5 different classification, and 2 more will get included in the next session. When it's come to the first classification, whether device senses and converts or just converts the physical phenomena. Means we people are measuring the physical phenomena. Physical phenomena may be electrical signals or mechanical signals or mechanical energy or whatever it may be. Means we are measuring the physical phenomena. That physical phenomena is get transferred into the required form. In that, the first one is primary transducer and the second one is secondary transducer. When it's come to the primary transducer, what is going to happen in the primary transducer? Here, physical phenomena is get converted into the output signal, required output signal. Means, before explaining the primary and secondary transducers, there are some transducers will mainly works on mechanical part and some of them will mainly works on electrical part. Means, when it's come to the mechanical part, I already explained how the mic will going to work. There, sound energy is get transmitted to the diaphragm. That diaphragm will going to get displaced to some level, due to which the energy transformation will going to happen. Means, the displacement device whatever present in that mic, that is mechanical part. Means, there energy transmission will going to happen from mechanical to mechanical. That is primary transducer. For that, one more example is thermocouple. I have written two bimetallic material will be there. That due to variation of the temperature, it will going to give the voltage form, whether it is in a analog form. In similar fashion, when it comes to the secondary transducer, in secondary transducer we already know here the mechanical signals is mechanical energy is get converted into electrical form. Means, in primary mechanical to mechanical, when it's come to the secondary mechanical to electrical. One more example for is Bourdon tube and linear variable differential transformer. When we observe the Bourdon tube diagram, in Bourdon tube the pressure will going to apply on the Bourdon tube, due to which the pressure, due to that pressure the link will get actuated. Their mechanical transformation will going to happen at the end of the Bourdon tube, due to which that will get connected to the load cell, it get connected to the coil, the windings present in that linear variable differential transformer. In that linear variable differential transformer we have primary coil and secondary coil, due to which the variation of pressure in that Bourdon tube, the lot of variations will going to happen within that windings. The movement of that windings in that, the movement will going to happen, due to which the voltage will get appear. There, Bourdon tube will be the primary transducer and the formation conversion of mechanical to electrical will be the linear variable differential transformer with the help of primary coil and secondary coil. The next is nature and type of output signal. When it's come to the nature and type of output signal, we have analog transducer and second one is digital transducer. When it's come to the analog transducer, here physical phenomena is get converted into analog output. In the digital transducer, physical phenomena is get converted into output in the form of pulses. There, physical phenomena, analog transducer means the signals will be in analog form. For that, very good example is a dial gauge. With the help of plunger movement of the dial gauge, the dial will going to show the reading in dial indicator in the form of rotations with graduations present over there. That is the analog transducer. When it's come to the digital transducer, I'm going to give the example of encoder. Encoder or tachometer. Tachometer is a device used to measure the speed of the vehicle. There, the plunger will going to get attached to the rotation of the shaft, due to which the rotations will get converted into digital signals. Means, in digital transducer, physical phenomena will get converted into digital form through pulses. Analog transducers are continuous time variant. Digital transducers are get converted into binary form in the form of pulses 0 and 1. That is about the nature and type of output signal. Next, the classification is whether they are self-generating or externally powered. Means, it is self-generating or externally powered. With the aid of some external power supply, the transducer works or not. That is very much important. When it's come to that point, we have two types, active transducer and another one is passive transducer. When it's come to the active transducer, here the electrical power is not required to run the device. Means, without the electrical power, the transducer will going to work. For that, I have written the piezoelectric crystal over here and photovoltaic cell. Next, in active transducer, with the help of own power, one more example for it is thermometer. In that thermometer, we have mercury present over it. It will going to sense the temperature of any of the system or the device, due to which the capillary rays of the mercury will going to happen. Means, there without any aid of the external power, the mercury is showing the results in the form of graduation, they are present over there. Next is passive transducer. Here with help of external power, the transducer will going to work. That is resistor temperature detector. Means their temperature is get detected with the help of variations of the resistance. Here external power is required. Another one is a differential transformer with variation of the differential, means from primary coil to the secondary coil, the signals will going to generate. Means some external power is necessarily required for that particular transducer. That is about whether they are self-generating or externally powered. Next, fourth classification is its purpose in measurement system. What is its purpose in measurement system? When it's come to its purpose in measurement system, we have the first one is input transducer and the second one is output transducer. Here in input transducer, we can clearly observe that non-electrical quantity is converted into electrical signal. When it's come to the output transducer, electrical quantity is or electrical signal is get converted into non-electrical quantity. For this, very good example is mobile phone. For making a phone call to any of my friend, if I take the phone and keep on typing the numbers, after pressing the ring button, you can clearly observe that the ring button is going to transfer and we can clearly hear that the sound of the ring button. There, here sound waves or the sound signals are get transmitted or received from the receiver over there, their transducer will be there. That transducer in that particular device will going to convert the signal into the electromagnetic waves. Means after getting conversion of the electromagnetic waves, that signals again will get reached to the another mobile, their receiver will be there, due to which the receiver will going to transmit into the required form. Again that signal is get transferred to the sound waves. Means the main objective is sound waves will get transmitted to electromagnetic waves. Again electromagnetic waves will get transmitted as received as a sound waves. Means there will lot of transformation will going to happen with the help of electronic processors. There two ways the transducer will going to act. From sound waves to electromagnetic waves, again transducer will be there. Again from electromagnetic waves to sound waves, transducer will be there. Means my voice is clearly visible to my friend or any of them when I make a phone call. Means that is well going to happen in the same manner. Means there the input transducers and output transducers will going to play a major role. Input transducers, there sound waves to electrical signals, again from electrical signals to the non-electrical signals. Means that sound wave is a non-electrical signal. That is about the fourth classification. Okay, the next classification is method of conversion of energy. In that we have based on the medium will going to act or the based on the energy transformation going to take place in any of the system or any of the devices. This method of conversion of energy will classification comes under. In that the first one is mechanical linkages. When it's come to the mechanical linkages, you can clearly observe that in mechanical linkages, the transmission of energy will going to happen from mechanical energy to the mechanical energy. Means their mechanical linkages will going to transform linear motion to rotational motion or rotational motion to linear motion. In similar fashion, when it's come to the fluid, in fluid we have a float is a very good example for it. The float is get attached to the tank, in a water tank or in the sump. There once after the pump is getting on, the pump will going to lift the water from the sump to the water tank. There the water keep on going to fill the tank. When it reaches to the higher level or the top level of the tank, the float will going to detect the level of the water, due to which the float level indicator will going to give the signal to the pump to switch off the motor. When it gets switched off, the float will going to act as a level indicator. It is also one of the transferring medium. In similar cases, when it's come to the properties of material, here I have written 4 different properties of material: resistance, conductance, and capacitance, and expansion. Means their properties of due to variation in the properties of the material will going to act. This is the 5th classification. When it's come to the 6th classification, type of sensing element present over there. Means in many of the devices the sensing element is present, due to which the object will be get detected or the signal will be get transformed. When it's come to the transducer, the sensing element and the signal condition is very much important, because the sensing element will going to sense the energy or the one form of energy to the one form of the energy and get converted into the another form with the help of the signal conditioner. Here the first element they are using is elastic element. The most probably elastic elements are used in mechanical linkages. This elastic element where the very good example is spring, means the due to deformation of the spring, the displacement of or the compression of the spring will going to move from original position to the displaced position. There the spring will going to play a major, means elastic deformation will going to happen. Next is the mass element, means due to inertia the mass element will going to defect, means it will going to react. There the accelerometer is very good example, means next is with the help of thermal sensing element, means here it will going to sense the heat of the system. In thermal sensing element it will going to sense the heat of the system. Very good example is thermometer. There the medium is mercury. With the help of mercury the capillary rise will going to happen once after measuring the temperature or heat of the any of the system. The next fourth one is hydropneumatic element. In hydropneumatic element, here hydraulic pressure is get converted into pneumatic pressure. There the float level is a very good example. Here the fluid level is get increased to the required level, due to which the float will going to react, and orifice and venturometer is one more example for it. There orifice and venturometer works on the principle, works on the variations of or the changing of from velocity to pressure or pressure to velocity. This is the sixth classification of the transducer. And the last classification is type and nature of measurement, means measurement is very much important before going to use any of the transducers or sensors. When it comes to the nature of measurement, the first one is mechanical transducers. You can clearly observe mechanical transducers means some mechanical properties or some mechanical features will going to get observed over there, means force, displacement, velocity, acceleration, pressure, viscosity, vibration, etc. These things will come to the picture in mechanical transducer. Next is electrical transducer. There electrical measurement will be there. There resistance, capacitance, then inductance, etc., etc. These things will come to the picture. And the third one is electromechanical transducer. In electromechanical transducer is nothing but there. Very good example is motor. Motor will going to convert one form of energy into another form. That is nothing but electrical energies get converted into mechanical rotations. Next, fourth one is electromagnetic thing. Here electrical signal is get converted into magnetic field. For that very good example is Hall effect sensor, means the nature of curves passing through the material, it will get diverse when you bring magnetic force over it. That is about the Lorentz force, that is Hall effect sensor. And the fifth one is electrochemical. There pH meter is used to indicate the pH value of any of the fluid. And the last one is electroacoustics. Here the very good example means electrical signal is get transferred to the sound waves or the acoustics. The name itself clearly indicates earphone, and the loudspeaker is are the examples. This is regarding about the classification of transducer. The next topic is sensors. Before getting into the topic of the sensors, we know few of the things regarding about the sensor. When it's come to human beings to do some various tasks or to perform various tasks in the environment, we're going to deal with 5 different sense organs in our body, means eyes, ears, nose, tongue and skin. With help of this, we're going to perform lot of operations, lot of tasks in our daily life. Without overcoming any of the disturbances, these sense organs will going to play a major role in many of your life. When it's come to that point of view, a sensor is used to measure the physical variable, means sensor is used to measure the physical variable. You can clearly observe here it is used to measure the physical variable. Yeah, I have written the block diagram of the sensor. Here sensors will going to measure the physical variable. Here I have written the 2 block diagrams. One is the transducer, another one is signal conditioner. I already explained regarding about the transducer. In transducer, sensing element is there and signal conditioner is there. When it's come to the sensor, transducer will be there, signal condition is there. Means physical phenomenon will going to measured by the transducer, due to which the physical phenomena get converted into one form or to the another form, then that is the signal conditional, and the digital signals or the electrical signals are will be the output of the any of the sensors. That is about the definition and the explanation of the sensors. And one more thing, for all the sensors, calibration is very much important, because in sensors many of the mechanical linkages were present and electrical linkages will be present, because there without the calibration the sensor will not going to give the accurate values and the required for values in many of the applications. Next we have the classification of sensors. When it's come to the classification of sensors, mainly I am going to classify it into two types, internal sensors and external sensors. Even in our body we have internal sensors and the external sensors. When it's come to the internal sensors, these sensors are used to measure the internal reactions or the internal parts whichever get connected into any of the robots or any of the machines. Means internally get connected, their torque will going to get induced, force will get going to induce. To measure that, they are using the position sensors, velocity sensors. Next we have external sensors. These external sensors are used to measure the environmental conditions in our body. If eyes, ears are the external sensors, we can clearly visualize through our eyes by detecting the or observing any of the medium or any of the things getting over there in our daily life. Means in surroundings we can clearly observe, that is the external sensors. Here temperature and visual sensors and proximity sensors are used in external sensor. And one more classification is about contact type and non-contact type of sensors. When it's come to the contact type of sensors, these sensors are nothing but they will going to act like a touch sensor, tactile sensors and binary sensors. When it's come to the contact type of sensors, we can clearly observe that in contact type of sensors, a very good example is our skin. When skin will get touch with any of the surface or any of the member, it will going to react and give the information to our brain. Means in similar fashion, touch sensors and the tactile sensors are used in many of the robot applications, because once the robot will going to lift the object, whether it is a plastic material or whether it is a metal or whatever it may be, or a glass material, robot should get touch the material. It should know that it's a type of material that will going to I am dealing with, whether it is a plastic, metal or whatever it may be. When it's come to its memory, then it will going to decide it how to hold that object or how to hold that material. That is about the example of contact sensors. Next one is regarding about the non-contact type of sensors. Here there is no physical contact between any of the medium. For that, very good examples are capacitor sensors, inductance sensors. Means object will be detected based on the range of that particular sensors. Here these sensors will going to transfer the waves or the signals to the object to be sensed, due to which the output will get generated in the form of the electrical signals by sensing the element, whether it is on and off or getting connected to the buzzer sound or whatever it may be. These two are the major classification of internal and external classification, internal and external sensors. Here I have explained regarding about the internal sensor, external sensor, and one more classification regarding about the contact type and non-contact type of sensors. This is regarding about the classification of sensors.